Moving on to chapter 13, section 13.1, we had vector valued functions, which was just a way to talk about parameterizations. That's really all a vector valued function is in this class. It is a function that takes as an input a scalar, and then the function spits out a vector. Okay. In this section, we practice some basic parameterizations. Basic parameterizations that you should be familiar with are that of a circle. All right. So in the xy plane, for instance, you can trace the circle starting here at t equals 0 and then moving in this orientation. Such an example here would be r of t equals cosine t sine t. And of course, we'd need some sort of domain, let's say t between 0 and 2 pi. That's an example of a parameterization. We could also do this in 3D if we want, but this section here was just to introduce you all to parameterizations. So, in the grand scheme of things for the final, is there anything you really have to do with section 13.1? Not really, because you've been using parameterizations all semester, and we're certainly using them a lot now when we are talking about surface integrals, so we're doing surface parameterizations, and when we do like Stokes' theorem, where we can change from integrating over a surface to integrating over the boundary of that surface. So whether we're doing a surface parameterization or we are doing a path parameterization. In section 13.1, these were all one-dimensional parameterizations because there's one input, and this is spitting out a vector. So this is going to trace some sort of path, a one-dimensional path, because we have one variable.